The name of this activity is folded number lines, making your own number line. So if we were in class, I'd be able to walk you through these steps together. If you would like to do this at home, if you have access to a ruler and scrap paper, that would be great. Down below, you can kind of see just like the breakdown of how you could make your own detailed number line. Because in theory, on tests or different problems that you have in the future, a number line won't always be provided for you. And so if you could make your own, that's a really great reference tool to use when working out these kind of problems involving positive and negative numbers. But because we're doing this digital learning, I just provided one for you. So you can kind of skip over that for now, and we can just use the one that I provided on the middle of the page. So you can see a few labels here. We've got the origin at 0. That's a good term just to know. And then we can see the positive numbers are to the right, the negative numbers are to the left. Use your number line to answer these questions. Which number is the same distance away from 0 as is the number 4? So, if I wanted to be exact, I could pull out a measuring tool, and looks like I can tell that 4 is about 3 centimeters away from 0. So, what else is about 3 centimeters away from 0? And if we look, it looks like -4 is also 3 centimeters away from 0. -4 is the same distance away from 0 as +4. Which number is the same distance away from 0 as is the number -7? So once again, we can pull out a measuring tool, and we can see that -7 is about 5 centimeters away from 0. And then if we wanted to go the other way, and it looks like +7 is also just shy of 5 centimeters away from 0. 7 is the same distance away from 0 as -7. Number 3, now this is important. So two numbers that are the same distance from 0 on the number line are called opposites. So that's opposite numbers. Are any two numbers that are the same distance away from one another on the number line. So some other examples, 1 and -1. So let's just write a few. 2 and -2 are the same distance away. And so on and so forth. Essentially, any positive number and its version with the negative number are equidistant or the same distance away from 0. So we could also do 7.5 and -7.5. Those are also opposite numbers. Or 1/2 and -1/2 are opposite numbers. They don't just have to be whole numbers. You can also have mixed numbers or decimals or fractions and still have opposite numbers. And if I wanted to graph 1/2 and -1/2 on the number line, that would be 1/2 a unit away from 0 and 1/2 a unit away from 0 the other way for -1/2. Excuse me. All right. So next page, I copied the number line again. So it says, determine how far away the number 5 is from 0. Then choose a positive number and a negative number that is each farther away from 0 than is the number 5. Okay, so if I measured 5 looks to be about 3.5 centimeters away from 0. Halfway in between 3 and 4. And I can tell that 8 is about 5.5 centimeters away from 0. So that's farther away from 0. So let's say 8 centimeters. And if I want to do the opposite, I could do that as well. And I can see that -8 is also about 5.5 centimeters away from 0. And so in the future, you won't always need to use a ruler. Once you just know the rule about the larger the number, the farther away from 0. This is just, using the ruler is just kind of an instructional tool to kind of get that idea across. So determine how far away the number -2 is from 0. Then choose a positive and negative number that is each farther away from 0 than is the number -2. So instead of using the ruler for this one, let's say we didn't have a ruler. We could also solve it like this. This is 2 units away from 0. So a number that is farther away from 0, well, how about a number that is 3 units from 0? Like -3. That's farther. -3, as we can tell, is definitely farther away from 0 than -2. So -3 and +3 are both farther away from 0. Alright, and now down below, here is a number line with some points labeled with letters. Determine the location of points P, X, and Y. So, once again, if you have a ruler, this could be helpful. If you don't, you can also just kind of estimate the distances. So, you can see here the positive side of the number line is kind of fully laid out, whereas this negative side is not. So this looks to be about a little centimeter, so maybe I could put one here as well. And so P looks to be the same distance from 0 as 2. So I'm going to say P is probably -2. Okay. And then how many extra spaces could we put in between here? The farther away from 0 you get, the more difficult it is. So let's just see how many centimeters away X is. X looks to be about 2 centimeters backwards from 0. So then what number is forward 2 centimeters? Three. Right? No, I'm actually going to say that's about 4. That's about 4 units away. Right? 1, 2, 3, 4. Okay. And then Y would be looks like 4.5 units away from 0. So then what positive? That would be the opposite of the positive number that's 4.5 away. And that looks to be about 7. So Y would be -7 then. So opposite numbers, once again to review, are numbers that are an equal distance away from 0. Alright, so now we're at our lesson summary. So once again, this is an important thing to just read over yourself. So just kind of restating the main ideas from the lesson. So once again, the number 4 is positive, so its location is 4 units to the right of 0 on the number line. And the number -1 1/10 is negative, so its location is 1.1 units to the left. So that would be like about here. So just knowing that the positive is to the right, negative is to the left. Numbers that are equidistant from each other, from 0, like 8 3/10 and -8 3/10, -3/2 and 3/2 would be considered opposites. And an important piece that we didn't go over in the lesson is this new term, rational numbers. So throughout school, you've mainly just been talking about positive numbers, and then in recent years, you've gotten more into fractions and decimals. So a way to talk about all positive and negative numbers at the same time, including those with decimals and fractions, we call those rational numbers. So all of the fractions and their opposites are what we call rational numbers. And here are some examples. All right, and here are your big ideas. Make sure to copy those down and complete your practice problems and exit ticket.